So again, you can look at these points from a distance, and you can kind of picturize how these points are. So what can you tell me without using a pen and paper, just by looking at these points?
So both points are in the different hemisphere. One is in the northern, one is in the southern hemisphere.
Yeah.
And there might be a chance that they might be lying on the same meridian, since we have the longitudes in different sense, like west and east, and they both have different values.
So how do you know
that? That will first confirm.
We'll add these two and see.
Add both of the longitudes.
So this is 166 degree 57 minutes, and this is 13 degree 3 minutes. So we saw yesterday the degrees in longitude is 3 digit and minute is 2 minute, right? 2 digit. Yes. So is it 180?
Yeah, it's 180.
Yeah, it is adding up to 180 degrees 0 minutes, and you can also see the next check is the sign. One is west, other is the east, and we saw what happens if both are same sign. It is not going to be in meridian and anti-meridian. Right? We saw it yesterday.
Yeah.
Right? Therefore, these points definitely lie on a meridian and anti-meridian. What else can you say about the point? They lie on different hemispheres.
Yeah.
Anything else that you notice? Other than the fact that they lie on different hemispheres.
The latitude value is same.
Yeah, they are on the same latitude, one to the north, other to the south. Alright, so let's draw this diagram here. Again, in such cases where your meridians kind of add up to 180, side view is going to be a better option. And in this case, since one is north, other is south, top view is not really going to help you. So side view is the best option here. So we have the north, south, east, west directions. So we can see here that they have the same latitude values.
Yes.
What about the sign? But
sign.
Yeah, opposite sign. Correct? Same lat values.
Yeah.
This can be both north, but one is north, one is south. Therefore, by opposite values. So let's draw those latitudes first. One is 3547 north.
Yeah.
And the other is 3547 south. This is a commonly asked question for the exam again. These type of points, because the answer is very easy if you can identify the type of points given. So we can take any of these meridians as 166.57. So it's not that the meridian towards your east has to be an easterly longitude. No, it can be westerly as well. So it's 166 degree 57 minutes west here, and this is going to be 13 degrees 3 minutes east. Right? Let's now mark the points here. Intersection of 3547 with 166.57 is J. Juliet.
Okay.
And over here you get kilo.
Okay.
Now, what can you say about these points? Okay, so what is the thing? If the points lie on a meridian or anti-meridian, then the shortest path between them will pass through the nearer pole. Right? Which of these is the nearer pole here?
So they both are same, like from north or south.
It doesn't matter whether you travel along north or south, right? What is the reason for that?
Yeah.
So if you want to go to be the angle, so let me find the angle here.
Yeah.
We connect this, and this angle is what is 35
degree 47.
And this is going to be the same 35 degrees
35 degree
47 minutes, right? Therefore, we are looking at a distance of J via north all the way up to K. So we're looking at an corresponding angular change of so much at the center of the earth. What do you think that angle is going to be if we add up? So we can see that there is a 3547 here and 3547 here, and the rest of the angles. If you try to find out this angle, this total angle, so you can see it is exactly a straight line, right?
Yeah.
And therefore the angular change is going to be 180 degrees. right? Since the total angle is 360, this angle is also going to be 180 degrees. Therefore, the angular distances corresponding to them is going to be same. And for that reason, it doesn't really matter whether you travel through North Pole or South Pole, you're going to have a shorter distance. It's going to be the same. Right? So look at these 2 points there. We can find the answer now, obviously. 180 degrees, you multiply with 60, convert that to minutes. We are measuring along a great circle, and therefore it's so many nautical miles. That part is fine. But what you have to understand here is, in this particular question, how is this different from both the previous questions we have done? In all 3 questions, we have this longitude adding up to 180 with opposite sign. And how is this different?
It was different just because that it was the angular displacement, or the angle was the same 180 degrees only. So it was
so why,
it had
why
both
is it 180, 180?
It had both the nearer poles.
Yeah, so what is the reason for that? How come the angle is 180, 180? That's because we have...
Just because their latitudes are same.
So if you look at the very previous question, you can see the latitude values are closer, and that is why you find it, initially if you look at the figure, it is not very easy to find out whether it is to north and south unless you find the angle. That's because one was some 22 degrees, other was some 30 degrees, so it's pretty closer. But when it becomes exactly equal, they are exactly opposite. So what can you say about these 2 points? J and K. These points are very similar to these points here, north and south pole. 90 degrees, 90 degrees, same lat value, opposite sign, right? So what are those kind of points called as?
That antipodal.
Antipodal points, yes. So 2 points are said to be antipodal if these 2 conditions satisfy. The points, they have to lie on a meridian and anti-meridian. Second, they have to have same latitude values but opposite sign. If these 2 conditions satisfy, then you can say that the points are antipodal.
Antipodal.
Or they are diametrically
Opposite.
Diametrically opposed. Now what is the, so even without drawing the diagram, you can analyze that it is antipodal. What is the advantage of understanding this? Immediately you will understand that the angular change is going to be 180 degrees. You don't have to draw the diagram now, right? So 180 degrees angular change, when you convert that to minutes, how much will you get?
10800.
10800 minutes. Now we'll take a pause and see whether 1 minute 1 nautical conversion is possible. Yes, because we are tracking along the meridians, right? Therefore 1 minute is equal to 1 nautical mile. Therefore it is 10800 nautical miles. You can probably remember this number, 10,800 nautical miles. What is that? It is just that you're trying to travel from here. You are actually covering half the earth.
Yeah.
So when you cover half the earth, you would have covered an average distance of 1,800 nautical miles. Remember, this idea of 1 nautical mile is itself an average value. So whatever you find out is not the accurate value. It's going to change because the earth is not a perfect sphere like this anyway. Right? So we take all this 360 degree, all those things, assuming that's a perfect sphere. So it's an average value. What if we complete the entire, we circumnavigate the earth all the way around? So J to J, it's going to be double of this. Right? 21,600 nautical miles.
600 nautical miles.
Right? That's more like the normal circumference of the earth, if you can think about it. The circumference of the earth. Mainly at the equatorial plane, because actual earth it's going to change. Right? So what did you understand? That if you can identify these points as antipodal, you can directly mark the answer. You can save a lot of time here in this question. It's directly 10,800 nautical miles. Right? What is the same value in kilometers?
1 nautical mile is equals to 1.852 kilometers.
That's
So I'll
right.
multiply this by 1.852.
So we are expecting an answer that is kind of double, almost double this value, it's less than that, but double the value, right? So find out 10,800 into 1.852.
It's 20,000, approximate 20,000.
Yeah, 20,000 actual value.
It is 2,001.
Yeah, so 20,000 kilometers. Right? Now, be very careful with the options, because in the options they can give you 10,800 kilometers and then 20,000 kilometers. If you look, if you're so familiar and happy with this numerical part, you probably might go and click it, and wrong, because that's 10,800 nautical miles or kilometers. Then the answer would be 20,000 kilometers. So be very, very careful, not with the numerical part, not with the magnitude, also with the unit. That is one thing where people do really go wrong. After doing all these things, you just kind of scratch your pot at the end, which is the very sad part. So look at the options very clearly, think twice before you mark the answers, right? But another mistake which students make here is just by looking at these 2 points and adding up to 180, the longitudes adding up to 180, they will kind of assume the points are antipodal. Now this will make the points on a meridian and anti-meridian only. It's not going to make the points antipodal. For it to be antipodal, along with this condition, they must have same latitude with opposite sign. That's also a requirement. That is why all the previous 2 questions you saw, that the points, the longitude still added up from 180, but they were never antipodal, because the latitude values were not same and with opposite sign. And make sure the sign is opposite as well. If both of these are not, it is just like what we told you, having same sign. It won't work. Alright, perfect. So you can look at this particular question. You can see the values are a bit different, but still there's a catch in those points. That is what you have to identify in the question. They will not ask you a problem or 2 points which doesn't have any kind of such relations. There will be some kind of relation between them. Alright, yes, that's it. So you can copy this diagram and you can find out the answer.